This is a video walkthrough for the review for Unit 3. In 1 through 2, we're asked to find an angle that is between 0 and 360 degrees and coterminal to the given angle. Coterminal angles are found by adding or subtracting multiples of 360. So we can subtract 360, or we can subtract 360 times 2. We can subtract any multiple of 360, so I'm going to take my 980 degrees and I'm going to subtract 2 times 360, or 720, for a 260 degree angle, which is coterminal. For number 2, we have a negative angle. In order to produce a coterminal angle between 0 and 360, we'll have to add one full cycle, or 360, to that. So negative 140 plus 360 is 220. In 3 through 5, we have multiple choice. When drawn in standard position, we're asked in which quadrant a 470 degree angle terminates. So we can either draw a 470 degree angle, and if it's a positive angle, it will rotate counterclockwise. That's 360 degrees so far. An extra 90 will bring us to 450. 470 is 20 degrees after that, so that's going to terminate in quadrant 2. Another way to do this is simply to take the 470 degree angle and subtract 360 from it, and that gives us 110, which is between 90 and 180, so we know that's in quadrant 2. For number 4, we're given a negative 300 degree angle and asked in which quadrant that terminates. You may either do one of the following. You may draw that angle, and if we rotate negative 300, that's negative 270 plus an extra 30, and that will give us a negative 300 degree angle, terminates in quadrant 1. Or you may find a coterminal angle by adding 360 to it, and that will give us 60 degrees, which is another angle that we know terminates in quadrant 1. For number 5, we have an angle in standard position, and we have several different angles here. We're determining which one is not coterminal with the others. So I'm going to start with my smallest angle here, which is negative 440 degrees, or my least value, and I'm going to add 360 to that to determine a coterminal angle. Adding 360 gives us, looks like negative 80 degrees is a coterminal angle. That's not one on the list, but I'm going to keep adding 360 degrees. So if I add 360 to that, I'm going to get 280. Check my arithmetic there, which means that so far these two angles are coterminal with one another. And let's take 280 and add 360 to that, and that will give us 640 degrees, and then 640 degrees, and add 360 to that, and that will give us 1,000 degrees. So far we found that those 3 angles right there are all coterminal. 460 degrees is not on that list, so that angle is not coterminal with the others. And for numbers 6 through 13, we are asked to evaluate each trigonometric expression drawing reference triangles if necessary. And for number 6, we have an angle that is bigger than 360 degrees. For simplicity, sine of 510 is equal to the sine of a coterminal angle. So subtracting 360 from 510, we get 150. And so sine of 510 is the same as sine of 150 because they terminate in the same spot. And I'm going to draw a reference triangle for 150 degrees. That terminates in quadrant 2, and our reference angle is 30 degrees. Opposite is 1, adjacent is negative square root of 3, and hypotenuse is 2. So sine of 150 degrees is equal to 1/2. For number 7, we're asked to find the cosine of negative 60. Rather than find a coterminal angle, it would be probably easier just to draw a negative 60 degree angle. So for negative 60 degrees, we're rotating in a direction that is clockwise. If I rotate negative 60 degrees, then we have a 30, 60, 90 triangle. Adjacent is 1, opposite is negative square root of 3, and hypotenuse is 2. And so the cosine of negative 60 degrees is equal to adjacent over hypotenuse, or 1/2. For number 8, we're asked for the tangent of negative 120 degrees. Again, might be easier for us to draw this as is, or we can get a coterminal angle, which would be 240 degrees when we add 360. And for this angle, we rotate clockwise 120 degrees. Then our reference angle is a 60 degree angle with an adjacent side negative 1, opposite sides negative square root of 3, and hypotenuse 2. So tangent is the opposite divided by the adjacent, and that's a negative divided by a negative, so the result is positive, and we never leave a denominator of 1 because you can divide by 1 very easily. The square root of 3 divided by 1 is the square root of 3. For number 9, the cosine of 450 degrees. So I'm going to draw a 450 degree angle. 450 degrees would be a full revolution, 360, plus an extra 90. So there's a 450 degree angle. And so its terminal side will lie on the same side that a 90 degree angle will lie. And so this may be easier to determine with all smart trig classes. Cosine is positive on the right side. So cosine's positive in these two quadrants. Cosine is negative in these two quadrants. And so in between those quadrants, cosine will be 0. For number 10, sine of negative 90, we can draw a negative 90 degree angle, which is one that rotates from the positive x-axis clockwise 90 degrees. And so that's also at a quadrantal angle. Let's think about what we know about sine, all smart trig classes. And so sine is positive when we're on the top side in quadrants 1 and 2. Sine is negative when we're in quadrants 3 and 4. So in between is where sine is equal to 0. And so negative 90 is right in the midst of all of the negativeness of sine. So that means that the sine of negative 90 would be negative 1. For number 11, we're asked to find the sine of 390. I'm going to reduce that to a coterminal angle by subtracting 360. So that's the same as sine of 30 degrees. I'll draw a picture for a 30 degree angle in quadrant 1. And opposite is 1, adjacent is square root of 3, hypotenuse is 2. And so the sine of 30 degrees is 1/2. Now let's try number 12, the tangent of negative 180 degrees. So for tangent, we can make a drawing. And negative 180 degrees is a clockwise rotation that takes me halfway around from the positive x-axis. So it terminates on the negative x-axis. And there's a couple different ways you can approach this. You could approach this with a set of coordinates here, and the coordinates will be -1, 0 because the x value is negative, and our vertical coordinate is the opposite, and horizontal component is the adjacent, so opposite over adjacent is equal to 0. Another way that you can approach this is you can think of tangent as slope, and if we look at where the terminal side is, which is on the 180 degree marker, which is on the negative x-axis, so that would be 180 degrees, right? Or negative 180 degrees, doesn't matter which direction we went actually, and that's a horizontal line, and a horizontal line has a slope of 0, and tangent is related to slope. All right, last one. Tangent of -270 degrees. So -270 degrees is a rotation that is clockwise, and that goes through 3 quadrants, and the terminal side of that angle is on the positive y-axis. And if we approach this with the slope idea, tangent is the slope of that terminal side. That terminal side is vertical, and the slope of that terminal side is undefined. So the tangent of -270 degrees is undefined. For 14 through 17, we're asked to find the amplitude for each periodic function, and that will only apply to sine and cosine. The amplitude is equivalent to the vertical stretch factor, which is the number that is multiplying the sine or cosine function or its coefficient. So the amplitude in number 14 is +7. Remember that the amplitude must always be positive. The negative here serves the purpose of inverting the sine function, but it doesn't change the amplitude. The amplitude is always positive. For number 15, the amplitude is the coefficient of the sine, which is 1. For number 16, the amplitude is the coefficient of the sine, which is 4. And for number 17, the amplitude is the coefficient of the sine, which is 2. Notice that any of these could have been cosine functions, and the answers would have been the same. For 18 through 23, we're going to find the period of each periodic function. Now, period applies to sine, cosine, and tangent, and the period is 360 degrees divided by the value b, which is the coefficient of x in the cosine function, and that's for cosine and sine only. 360 divided by 5 is 72 degrees. For number 19, this is a tangent function. The period of the parent function is 180, so 180 divided by b gives us a period of 90 degrees here. For 20, the coefficient of x is 1. This is a sine function which has a general period of 360. 360 divided by 1 is 360 degrees. For 21, the period is 360 degrees divided by the coefficient b, which is 3/2. 360 divided by 3/2 is the same as 360 times 2/3, which is 240 degrees. For number 22, this is a tangent function, so be careful. The period is 180 degrees divided by the coefficient of x, which is 6, so the period here is 30 degrees. For number 23, the period is 360 because we're working with a cosine function, divided by the coefficient of x 3/10, which is 360 times 10/3, which is 1200 degrees. All right, for 24 through 27, we are asked to find the phase shift for each periodic function. The phase shift is the horizontal shift, which is caused by addition and subtraction. And since phase shift is a horizontal change, it is an input change, which means it's an inverse operation change. So the phase shift is negative 15 degrees for number 24. For number 25, we must have the input for the cosine function factored before we can tell what the phase shift is. So factoring 3 times x plus 7, and so the phase shift is negative 7 degrees. For number 26, since the coefficient of x is 1, it's unnecessary to factor because factoring out 1 doesn't change what's on the inside of the tangent function. So our phase shift is positive 6. For number 27, we'll have to factor again, so I'm going to rewrite this as 2 plus the sine of 1/3 times x minus 63 degrees. And so our phase shift is positive 63 degrees, or 63 degrees to the right. For 28 through 30, we're asked to graph each periodic function, 5 points for each cycle for sine and cosine, and 3 points per cycle plus asymptotes for the tangent function. For number 28, I'm going to use the new origin approach. The new origin approach identifies the translations, horizontal and vertical, that are applied. Here I don't see any addition or subtraction for the input x, so the coordinate there is 0, and the output coordinate I see a 2 that's added, so 0, 2 is the new origin. And so I'm going to mark that off with an X, and then I'm going to create a table of values for the modified function, that is the function that has all the addition and subtraction taken out of it, so that's just y equals 3 times cosine x. So for my table of values, x, cosine x, and 3 times the cosine of x, I'm going to use my quadrantal values for the inputs to the cosine, so 0, 90, 180, 270, and 360, and then take their cosines 1, 0, negative 1, 0, and 1, and then multiply each by 3, and then graph my points, which are indicated xy pairs in the first and last columns of the table, but relative to the new origin. So 0, 3 is 0 to the right of the new origin and 3 up from the new origin. Then we have 90 to the right and 0 up from the new origin, 180 to the right and 3 down from the new origin, 270 to the right and 0 down from the new origin, and 360 down, 360 to the right and 3 up from the new origin. And so the graph of one cycle looks like this. I'm going to fill in some additional points to show what the graph would do from that point, and we'll just mark these off. Every 90 degrees, there's one cycle on the right side, and then there's an additional cycle on the left side, or probably more, that can be graphed as well. For number 29, we have y is equal to negative 4 times the sine of 1/2 x. There's no addition or subtraction associated with this one, so we're just working with the new origin, which is the old origin. Let's make a table of values. And our table columns would be x, 1/2 x is in parentheses, and then sine of 1/2 x, and then lastly, negative 4 times the sine of 1/2 times x. Our input and output columns for the sine are the second and third, 1/2 x and the sine of it. So 0, 90, 180, 270, 360. And the sine values are 0, 1, 0, negative 1, and 0. To move to the right, we'll multiply each by negative 4. And then to move from the left, from 1/2 x, we have to double. So to get from 1/2 of a value to the whole thing, we have to multiply by 2. 0, 180, 360, 540, and 720. So now we can graph all those points from the new origin, which is the old origin. 0, 0, 180, comma, -4, 360, comma, 0, 540, comma, +4, and 720, comma, 0. That's an inverted sine function that has been horizontally stretched and vertically stretched. Let's indicate another cycle, or as much as we can graph to the left of that initial cycle that was graphed from the table. And that looked a little bit off, so I did not graph that point very accurately. All right, that's a little bit better. And there's the remaining portion of the cycle. All right, let's take a look at number 30. This is a tangent function. So for the tangent function, you may want to rewrite this in the form -2 times the tangent of x plus 1, so that we can observe that the only addition is outside of the tangent function, which is going to give us a new origin of 0, 1. I'll mark that off with a little x, and then make a table of values for the function that takes the addition subtraction out of it. So x tangent of x and -2 times the tangent of x. Our values are a little bit different for the input for tangent. They are -90, -45, 0, +45, and 90. And their tangent values are undefined, -1, 0, 1, and undefined. Multiplying each by -2. And then graphing. So from that new origin, we can start by graphing the asymptotes to the graph. And the asymptotes are 90 to the left of the new origin and 90 to the right of the new origin. And we can certainly graph some additional ones for those additional cycles that we'll graph. And they will be evenly spaced. So we'll have several cycles in here. So our points are, using the first and last columns from our table, we can graph those points relative to the new origin. So first point is 45 degrees to the left of the new origin and 2 up. 0, 0 is on the new origin. Next point is 45 degrees to the right and 2 down. Let's mimic those points in the following cycles. And indicate what the graph does. It should be getting very steep on the left and the right as it approaches the vertical asymptotes to the graph. And then we can graph some additional cycles there on the left by, again, just mimicking the pattern of the points on the other periods of the function. And moving on from there, we're going to write the equations of each periodic function. When writing each equation, there are actually a number of correct answers. There's actually an infinite number of correct answers. I try to anticipate the one that I think is easiest to write in the answer key, but in this video, I'm going to give several of the right answers, or at least 2 of the right answers. For number 31, I always love it when I don't have to have a phase shift. So I'm just going to start my cycle at 0 and look at this portion of the graph right there as one full cycle. So if that is one full cycle, what are some observations that I can make about this? I can observe that that is an inverted sine graph. So it's a sine graph because it starts in the middle. It's inverted because it heads downward initially. And so the other things that I can observe about it is the amplitude, or one of the other things that I can observe is the amplitude, and that amplitude is 4. So far what we know is that the value of A is -4. Now we can go about finding the value of B, which really represents, instead of vertical stretch, horizontal stretch, or compression. And the value of B is equal to 360 divided by the period, and the period is this horizontal length. And that horizontal length right there is 240 degrees. So 360 divided by 240 is 3/2. So that means that the value of B is 3/2. So far, most of what we found is applicable to either sine or cosine. If we did cosine, we'll do it a little differently. I'll attack that issue later, but we'll concentrate on the sine for right now. And then the other thing that I need to worry about is phase shift, which is C. And since we're starting right at 0, we're starting the cycle at its beginning is at 0 degrees, then there's a 0 phase shift. Since the middle of the graph is at 0, the horizontal or vertical shift is also 0. Remember that the vertical shift is actually the average between the highest and lowest values. Using all of that information, the equation to this graph could be y is equal to -4 times the sine of 3/2 times x. That being said, let's approach this a little bit differently, and we'll come up with a second way to look at this. If we use a cosine graph, 3 of the things that we found, the value of B, and the vertical shift, the value of B and the vertical shift, and also the amplitude will be the same. So our amplitude is going to be 4 still, but if we were going to use a cosine graph, we could, for instance, start at a maximum and end at a maximum. So I might use this as my full cycle of cosine. We still have a vertical shift of 0, but now we have a horizontal shift of -90 degrees because our cycle starts at, -60 degrees. Because our cycle starts right here at -60. The period's still the same, and the vertical shift is still the same, and our amplitude is still the same. And this time our A value will be positive because that cosine graph is not inverted. So another possible answer here would be y equals 4 times the cosine of 3/2 times x plus 90 degrees. So there are actually an infinite number of answers depending upon where you decide to start your cycle and whether or not it's inverted. Let's take a look at number 32. If I choose a 0 phase shift, we're going to start our cycle at 0, and this looks like it will be a cosine function. So if we want to start with shifts, then C, our phase shift, is 0 because we're starting our cycle at 0 degrees, and the vertical shift is the average of the high and low values. The high value is +4, the low value is -2. If I average those two together, that is, add them and divide by 2, that result is going to be d equals 1, and you'll see that horizontal line at d equals 1 is going to travel right down the middle of this cycle. Our amplitude is 3, And since this cosine graph is not inverted, our A value will be 3. Now we need to figure out our B value. The length of one full cycle is 360 degrees. And so B is 360 divided by the period, which is going to give us 1. So the equation of this cosine curve could be y equals 3 times the cosine of x plus 1. That's one possibility. What would happen if we explored it using a different trig function? So if we explored it using, for instance, sine, you could start your sine function, for instance, right here. So we can start our sine function at 0, and this sine function would be headed downward first, which means it's going to be inverted. In that case, our A value will not be positive 3, but negative 3. Our C value is the phase shift, which will be equal to 90 degrees, because that's where the cycle starts on the left. And then our D value is still 1, because that average of the high and low values is still the same number. And our B value is still 1. So this equation could be y is equal to negative 3 times the sine of x minus 90 degrees plus 1. Gives us the same graph. For number 33, this is obviously a tangent function. I'm going to choose this as my new origin. Notice that the asymptotes are the same distance left and right of that new origin. So we can just average those two together and find that new origin. So we can look at this and notice if the new origin is right here, then our C, comma, D, which is the phase shift, comma, the vertical shift, is 30 degrees, comma, 0. So C and D are 30 and 0. The next thing we need to find probably is B, and B is equal to 180 divided by the period for a tangent function. So B is 180 divided by, and the distance between those vertical asymptotes is, looks like 180 degrees. So from one vertical asymptote to the next, looks like a total of 180 degrees from left to right. That each one of those markings there is 30 degrees, so a total of 6 of them is 180 degrees. So it looks like B is 1. And so if B is 1, the last thing we need to find is the value of A. Since there's no amplitude, this will be a little bit less obvious. And so A is how much did the value that's equal to 1 get multiplied by. And so here, the easiest way to deal with this is to take the point on the graph that's exactly halfway in between the asymptote and that new origin, which is right there. Find the y value there. So when we go over 45 degrees, we go up by 1. That's the value of A. And so A is 1. This graph can be written as y is equal to the 1 times the tangent of x minus 30 degrees and plus 0, I guess, right? So no, we don't have to add anything to that. For number 34, we have something that's either a sine or a cosine. I like a 0 phase shift, so I'm going to start right here and use that pattern of a sine function. My phase shift then is 0 degrees, and my vertical shift is -2. Remember, -2 is the average of the high and the low values, which are -1 and -3. So that's our C and D. Now we need to figure out what A and B are. A would be related to the amplitude, which is 1. Since this graph is not inverted, it's a regular sine function, it's right side up, then A is positive 1. Next thing we need to figure out is B. B is 360 degrees divided by the period, which is 720, so that's equal to 1/2. So rewriting the function, y is equal to 1 times, so we don't need to write that, sine of 1/2 times x, and x has 0 subtracted from it, minus 2. So there's one equation that we could write. If we change this and rewrite it as a cosine function, for instance, we could start our cosine function right here at a maximum and then look at it this way. It would continue over here and finish the cycle. Then we've got a difference here, and that difference is that now we have a 180 degree phase shift. And so that's going to write this equation just a little differently. Y equals cosine of 1/2 times x minus 180 degrees minus 2. Now, of course, if we choose a different starting point for our cosine function, we're going to have a different phase shift, and we then also have a different sign, that is positive or negative, on the a value. So rewritten another way, this would be y is equal to negative cosine of 1/2 times x plus 180 degrees minus 2. All right, let's take a look at number 35. For number 35, we obviously have a tangent function here. Our new origin is the old origin because that's exactly halfway in between those asymptotes. And so our C comma D is 0, 0. And the length of one full cycle is 540 degrees. So if the length of one full cycle is 540 degrees, then our B value is equal to 180, because remember we're working with tangent, divided by 540, and so that's going to reduce to 1/3. And last thing we need to figure out is what is the A value? What's that vertical stretch factor? For that, make sure that you are finding the point that lies exactly halfway in between that new origin and your right side asymptote. So halfway in between 0 and 270 degrees is 135. Let's go down, and we're going down to 2 units below the new origin, so that's our A value is -2. So this graph's equation could be y is equal to -2 times the tangent of 1/3 times x. For number 36, we have many cycles. If you choose a 0 phase shift, then we'll have a cycle that starts at the bottom, meaning it's an inverted cosine, and so the A value here will be -3. The average of the high and low values is 0, so our new origin point is 0, 0, or C, D is 0, 0. We have one thing left to find, and that is the value of B, which is found from the period of the function. The period is 180, so B is 360 degrees divided by the period, which will be equal to 2. So this graph could have an equation y is equal to -3 times the cosine of 2x. That's one possibility. Let's change this so that we're graphing a different kind of function. Some things will change and some things will not. The things that might change are the sign of A, that is SIGN, whether it's positive or negative, and also the phase shift. So if we start, for instance, right here and end right here, and we have one full cycle, we still have a cosine graph. It's not inverted anymore, so A will be positive 3, and its phase shift is positive 90. So its equation would be y is equal to positive 3 times the cosine of 2 times x minus 90. So that's another possibility. We could also write it as a sine, and if we write it as a sine, then we might be starting in the middle right here, and that would be at a 45-degree phase shift, and then using a cycle of sine, and that would be a right side up sine function. So our phase shift will change, our amplitude will not. So y is equal to 3 times the sine of 2 times x minus 45 degrees. So we have a lot of different possibilities here. And that is it.